So let's see how we can define a fluid with negative pressure. We saw from the equation of state, P equal to W rho C squared, give subscripts here for the different components. And we saw that for dust, rho m, you had Wm equals 0. For radiation, W was equal to a third. We want a fluid that has negative pressure. That means that W must be equal to -1. Let's give this component the subscript capital lambda, and the W is equal to -1. This fluid, which is going to call dark energy, then has this equation of state, minus rho C squared. Now, from the fluid equation, we can learn something about the density of this fluid. Let's give subscripts here lambda for this fluid and substitute the equation of state. Well, we have simply rho times the derivative of a cube. So if you apply the product rule on the left-hand side, you have rho lambda dA cube dt plus a cube times the derivative of this component. And the right-hand side cancels with the first term. Therefore, you have that the derivative of rho is equal to 0. The density of this component is constant, meaning that it does not depend on the scale factor. As the universe expands, the density of this component is constant. This is very different from what we saw from matter that is conserved and therefore has a geometrical dilution with the cube of the scale factor, and radiation that not only dilutes geometrically but also loses energy, therefore falls with the fourth power of the scale factor. This fluid, if its density remains constant as the universe expands, it seems to be a property of space. This is why one of the interpretations of dark energy is vacuum energy, a property of space. As we get more space, we get more of it, the density is constant.